7.8 is kind of a change in gears right here. We've seen this stuff before, but now, like the graphs they're not x and y's anymore. They're just the one-dimensional number lines that we've seen before. And since they're inequalities, we're going to be looking at intervals as well to express our answers, because there will be an infinite number of values that would make these inequalities true, just like before. But now it's just slightly different with that polynomial quadratic twist to it. So maybe some factoring, maybe some quadratic formula if you want, but yeah, it's going to be fun. All right, so inequalities and quadratics solve the same way that equations are, which means that I'm going to ignore the inequality completely at the beginning of the problem. We will only consider the inequality at the very end in order to check our answers. And yes, as usual, as we love, answers will be in intervals.
So there is domain.
So yeah, it's domain because we are solving specifically for x. And remember, if you have just a less than or greater than symbol on the graph, we would use a open circle, rather. And then on the graph, we would use parentheses like this. Or in the interval, yeah. So if it's less than or equal to, if it's equal to at all, then we would close that circle up on the graph, and then the interval will have square brackets for these. Now, generally speaking with these, even though, because we're going to be having generally two answers with our quadratics, as we've seen, usually there will be two values that are included. Sometimes they go left and right, sometimes it's in between, in which case we only have one interval, but sometimes we have to unite these if they go in opposite directions. The graphs, I'm going to be making the graphs. From what I remember, I don't think they asked for the graphs, but I don't care. I'm just going to use them because I like them, so I can visually see where these intervals are and which values would make this true. So, like I said, we're going to solve these as equations. Then after you finish, or after you figure out what values you have, then you put those values on a graph. After that, you have to kind of check each interval, because sometimes it's not so direct with the inequality. And so that's why we solve these as equations. We're looking for where these dots go on the graph, which is where the interval changes from being true to being false, because that's where we go from equality to inequality or truthfulness in the inequality. So falsefulness, truthfulness, falsefulness, or sometimes truthfulness, falsefulness, truthfulness. Which doesn't have to make sense, but hopefully will. Again, I think the example will help, but here's what I mean by that. So on the graph, what you could have sometimes is you'll solve, and you say this value right here and this value right here would make the inequality, or the actual original, equal. Those are equals. And then you got to check, right? So you'd say, I got to check this interval right here, see if it's true. If it's true, then it's part of the interval. If it's not, then I put an X next to it, so that I know that it's false. And then you can check this one right here, and you say, well, maybe this one's false. Maybe it's true. If it's false, then I put an X. If it's true, then I put a check mark. And then you got to check this last one right here. And if it's true, then you'd say check mark. If it's false, then you put an X there. We're only concerned with the ones that would make the original inequality a true statement. And we shouldn't see equality in those, because that's where these points are, which we've seen. Just find any value that's in the interval, meaning, see how this one goes all the way to negative infinity? That means that you could use anything that you want, not negative infinity, but something, you could use something very large. You could use something that's right next to the equality right here. As long as it's in the interval, you can check it in the original inequality, see if it's true or false. Or right here, again, you're not checking with the values that are equal, anything in between to see if it makes the original inequality true or false. And then same with this one right here. So again, that may not make sense, but let's see an example now. Well, so solve and write the answer in interval notation. All right. So I look at this and I say, I'm going to take this inequality, x squared plus 8x plus 15, and I'm just going to make it equal to 0. Now, I know that it is greater than 0, but I'm not concerned with that until I get to the very end, when I find the values that make this quadratic equal. okay? So that's why we're solving it just like we've done before, and we enjoyed so much. Now my leading coefficient here, my x squared, is 1, so that's nice because I know I should be able to just split this up into two binomials with the x values, right? I just need two factors of 15 that add up to 8. So I would use 3 and 5. So, good, we want you to. So that's a positive 3 and positive 5. And remember, we want this to equal 0, right? So that means that either of these two binomials, which are factors, if we could get them to equal 0, then we would have something that would be true in the equation, although it would make the inequality false, which is why we're going to use open circles when we graph it. But my first binomial, x plus 3, if I could get this to equal 0, that'd be great. So I would just subtract 3 from both sides, and then I get x equals negative 3. Okay, so again, negative 3 is a transition point on the graph, which we will get to. Also, if I could get x plus 5, if I could get this to equal 0, it would still be a true equation, right? So I'd have to subtract 5 now from both sides again, and that would zero that out, and then I would have x equals negative 5. So before I continue here, just to interpret this, x equals negative 3, x equals negative 5, that would make this part of the inequality equal to 0, meaning, try it. You could replace the x with negative 3 or negative 5, and then you'd see that it would equal 0, which would make this false, which is why on the graph we will use open circles. But it transitions, okay, because that's where it becomes equal. So like I said, I know this is not asking for the graph, but it's going to help me out. So I know this would be 0, then negative 3 would be about right here, and then negative 5 right there, okay? So I have these values. Up here, excuse me, this is not equal to, so I would have to have open circles. Again, if you plug those in, negative 3 and negative 5, you get something equal to 0, which makes that inequality false, and so we have to use these open circles. Now, it's not enough to just say, well, it was greater than, so everything to the right is true. No, we can't do that because of all the stuff that we did, the factoring, and actually I'd have to look into that a little bit more, but either way, we have to check. Okay, so I've got to check this interval, and I just need one point anywhere in there to check. I got to check in between as well, and then I've got to check to the right as well, anywhere to the right. And again, it doesn't matter which value you choose. You just can't choose negative 5 and negative 3 because that would have made this 0. That's where it becomes an equality, not an inequality. So anything to the left of negative 5 will work. Now, I tend to use really large values just to kind of emphasize what is happening here. But, you can actually use whatever you want. To get used to this, just understand, I'm going to go one value to the left of negative 5, which is negative 6, okay? So this means that I've got to go back to the original inequality, which is x squared plus 8x plus 15, and that needs to be greater than 0. We're checking for truthfulness, and I just chose an x value that is negative 6. Okay, so calculator would be nice here. Let's see what we get. So when I put this in the calculator, I got 3, and the inequality would say 3 is greater than 0. Yeah, that's true right there. Okay, so since it's true, at least for me, I'm going to put a check mark on that interval right there. Now, just knowing that, and since this is new for us, I am expecting this one to be false. And then the one here in orange, I'm expecting that to be false. The one in blue, I would also expect to be true. Why is that? Because it generally alternates. Generally. I'm sure there's reasons for that. I just don't care about them right now.
You're going to check in negative 4?
So yeah, we got to check again. And yeah, I got to check that orange interval. So yeah, I'll just go right in between there. We'll try negative 4. Okay, so again, I got to use the same inequality. It's x squared plus 8x plus 15. It should be greater than 0. So again, I don't know if it is, so I got my question mark, but I'm using negative 4. All right, so that's going to be 31 minus 32. I got negative 1.
So it's false.
Greater than 0. Yeah, that one right there, that's false right there. Since it's false, it's not part of our solution interval. So again, I got my x to show that interval is false. Now, let's try the blue one. But it's the same interval. It's the same inequality. X squared plus 8x
What number are you gonna go with?
plus 15. Yeah, I'm going to choose. You can choose whatever you want. I'm going to go 0 on this one because 0 is so great to work with. And if I can use 0, which I can in this one, I will if I ever see it in the interval. So I got a 0 there, and then it'd be 8 times 0. See if we can fix that other one. That's a 0. Okay, so this one, if you figure it out, you can put it in the calculator if you need to, but I know anything times 0 is 0. I get 15 is greater than 0, and this is true. So I put a check mark here, and as fun as that is, like, okay, that's a lot of work, and it's enjoyable work, so that's great. This is not done, right? It kind of is. It's just we got one last thing to do, and that is to actually show the interval. So the interval, let's give ourselves some space. The interval, the ones that are true are part of the interval, meaning that the green one is true. Well, the green one goes from negative infinity, and then it stops there at negative 5, which is not included. So I got a parentheses right there. Now, the orange one, which was between the negative 5 and 3, is false. So I'm going to have to unite this with the other one that is true, which starts at negative 3, which is not included. So there's parentheses, and this goes all the way to infinity. I'm looking at the blue line, which is also never included. And this right here is the interval, which makes all the values in this interval would make the original inequality true. So that also means if you look at the graph here, I chose negative 6 in the green interval, which means you could go anywhere to the left of negative 6. You could choose 100 million. You could choose, negative 100 million. Negative 10, you could do negative 5.0001, and you would still get a true statement in this. Same with in between. This would show any value between negative 5 and negative 3 would make the original inequality false. So if you tried negative 3.000001, it would make this false. Same with negative 4.999999, that would make this false. Okay, which is why it's not included. Any values would make this false, but we only have to check one, and that's the great news. We don't have to check all of them because I think only Chuck Norris could do it. But the blue one as well, anything to the right of negative 3 would make this true, this one true. And so you could choose 100 million. You could choose negative 1. You could choose negative 2. You could choose negative 2.999999, and it would be close to 0, but it would still make it true, okay? Because it would still be something that's even just a little bit greater than 0, and that's okay. So any values in these intervals, these two intervals, hopefully the color coding helped there, but yeah, these two intervals, boom, true. Solve and write the answer in interval notation. 15x squared plus 4x is less than or equal to 4.
We gotta make
Try it
it
out.
equal to 0?
Try it out. So first up, let's do what we did on the last one. Like I said, I'll do this twice so you can see two different ways. You choose the way that you like the best. So right here, again, I'm going to treat that like an equal sign. And so I'm going to apply a principle of equality. So I'm going to subtract 4 from both sides because we do need this to be equal. So like I said, I'm treating it like an equal sign. I'm going to make it equal to 0. So now I've got 15x squared plus 4x, and then minus 4. Make sure, I forgot to show the minus 4, but I'm purposely offsetting this minus 4 right here because I don't want to combine it with any of the other two terms. It's not a like term that you can combine with that other stuff. So make sure you keep it separated. Now that we have that, I need to take the a value, 15, and multiply it by the c value, which is negative 4, that makes it negative 60. I need two factors of that product, negative 60, to add up to the middle coefficient, which is 4. So I guess 6, oh, well, I just saw the 0, so I said 10. Lucky guess. I was also thinking 3 and 20, but 6 and 10 is going to work. To make that positive 4, the 6 will be negative. Now, since I'm using factoring, I'm going to take that 4x and split it up into those two factors of negative 6x and then positive 10x. And again, it doesn't matter which order you put this in, but now I have 15x squared minus 6x's plus 10x's minus 4, and this should equal 0. So I'm factoring by grouping because my leading coefficient was not a phantom 1. And that's okay because we can factor by grouping. So right here from the first set, it looks like I would factor out a 3 and an x, yep. So I would then be left with 5x minus 2. And again, if you just distributed that 3x back in there, you should get the same 15x squared minus 6x. And then the second set, I'm going to factor out, it looks like a positive 2 alone. Okay, so that leaves me with 5x minus 2, which it should, right? When we factor by grouping, these two binomials should be the same from those two factors. And then this equals still 0. So now that I have that, I can factor out the 5x minus 2. And then the other factor, just whatever was left from those two terms, which was 3x and positive 2. This equals 0. Now, of course, I still have the inequality, but like I said before, I don't care about the inequality. I'm solving it like I would an equality, because this is going to tell me the transition from truthfulness to falsefulness in the intervals and on the graph. But now I've got those two factors. If I could get them to just equal 0, those two factors, then I could get a true statement out of my equality. So 5x minus 2, if that could equal 0, that would be true. So right here I would add 2 to both sides, and then I'd get 5x equals 2, and then I'd divide both sides by 5, and I'd get x equals 2/5. Now, it's okay to have a fraction. I'll get to the graph here in a second, but let's solve that second one. So this one, showing that 3x plus 2, if I could get that to equal 0, that equation would be true. So to solve it then, we'll subtract 2 from both sides. So 3x now equals negative 2. And then divide both sides by 3, and we see that x equals negative 2/3. And it's okay that we have fractions. So now that I have that, I would graph it, and then I will find the intervals. But I'm probably going to need more space, so let's give ourselves more space there. So 0. 0 would be, I'm just going to put it in the middle. My positive would be to the right, so 2/5, put right here. And then negative 2/3 we'll put somewhere over here. I really don't care that they're proportionally away from 0. I don't care about that.
That's irrelevant, right?
Fully irrelevant when I'm graphing, especially since it didn't ask for a graph. So I'm just using the graph to create the interval. Now up here at negative 2/3 and 2/5, up here it says it's less than or equal to, which means that we could get equality from these. And that also means that I'm looking at negative 2/3 would make the original inequality true, so it's a closed circle. But same with 2/5. If you plug that into that original inequality, you'd get a true statement, not because it's less than, but because it would be equal to. So I got closed circles there. And so in my interval, on those two values, I'm expecting the square brackets. Now I got to do some testing. So I will test to the left of negative 2/3. I will check between negative 2/3 and 2/5, and then I will check to the right of positive 2/5. So let's get to it then. Let's go back to the, now I am using the inequality, right? I've got 15x squared plus 4x. This should be less than or equal to 4. It should be, but it may be false. Let's see, what value am I going to use? That's negative 2/3, so I'm going to choose negative 1. It's pretty close to negative 2/3, but it still is to the left, and that's all I need is any value to the left. Negative 1's pretty easy to work with, so I've chosen to use it. And so using a calculator for this, 15 minus 4, I get 11, is less than or equal to 4. Well, I was checking for truthfulness, and I just found that it's false. So since it's false, I'll put an X on that interval so I know that it is false and it's not part of our solution set, so it will not be part of our interval either. Let's try the next one. So again, 15 x squared plus 4x should be less than or equal to 4. Question mark there. I'm going to choose 0 because 0 is always a nice value to work with. And if I can use 0, I will. That's a 0, by the way. Well, I would get 0 is less than or equal to 4, and that right there is true. So I'll put a check mark on the interval. And going back to what we saw in that last example, if we get falsefulness here, then it usually alternates. False, true, false. Okay? So this next one, I'm expecting something false, but maybe not. Let's find out. So yeah, let's just make sure. So 15x squared plus 4x. This needs to be less than or equal to 4. And yeah, let's choose, because 1 is to the right of 2/5, and 1's a very easy value to work with. So we're checking for truthfulness by replacing the x's with 1. It's really 15 plus 4, which is 19. And 19, it's saying 19 is less than or equal to 4. Well, last time I checked, that's false. Since it's false, I'll put an X on that interval. And so it's not asking for the graph, right? I made the graph because it helps me. You don't have to. I hope it helps you, but it doesn't have to. So some students are like, I don't want to graph it. Okay, you don't have to. But now that we have it, may as well use it, and I need the interval because that's what it actually asked for in the beginning, is the interval, not the graph, not really the inequality, just the interval right there. So the part that's true, it starts at -2/3, which is included, so I have a square bracket there, and then the interval goes all the way to 2/5, which also is included, so I would stop it right there. And again, this tells us anything to the left of -2/3, you could choose anything. And if you plugged it back into the original inequality, false. This also means anything in between -2/3 and 2/5 would make the original inequality true. Or if you chose anything to the right of 2/5 right there, again, it would make that original inequality false. Now, that's solved, so let's box that in, just so we remember that it is solved. But like I said, I'm going to show you how to find these x values a different way. This second method still includes the changing of this format. 15x squared plus 4x is less than or equal to 4. I still need it in its quadratic form, the standard form, which means I'm still going to change this into 15x squared. I'm going to skip the step because we already showed it, but I just subtracted 4 from both sides, right? So I would still need this. And again, I'm still looking at it as though it were equal to 0. And so this method, if you were to do it, it would still give you the same answers of x equals 2/5 and also x equals -2/3. And I'm not going to tell you what it is yet, but hopefully by the time I finish here, you will know what I'm talking about. Okay, so up here, yeah, some of you guys got it. I see the a value is 15. So it'd be 4 there times 15. 2 times 15. I see my b value is 4. So I'd have a -4 right there, and then 4 squared. And then the c value is -4. Okay, this is the quadratic formula. Okay, now that I made that minus instead of plus right there, thank goodness, we'll get the correct answer. Now, if you, let's see, because I already put this in my calculator while you guys were trying it. For the plus sign here, if you do the plus, then you'd get, because this is x equals, by the way. If you use the plus sign, then that's how I got a 2/5 on that one. If you use the minus sign, that's how we got the -2/3.
Fancy that.
Yeah, so to me, just because it's a formula and the calculator will do all the work, like, I'm okay with that. Now, so a couple things. Is it possible to make mistakes while you're factoring? Of course there is, right? And plus, it may just take a lot of time with trying to find your factor pairs that add up to the middle coefficient. But we know as well, as you've seen me do, it's possible to maybe enter this in incorrectly. Maybe I write it down incorrectly. And so is it possible to make mistakes this way? Yeah. But I tend to trust the calculator a little bit more than I do myself with some of this stuff. But doing it by hand, showing all this work right here is also beneficial because you can kind of see each step as you go. And then it's easier to trace where you made mistakes. If you're doing it on a calculator like this, yeah, it can be harder to figure out, well, where did you make your mistakes? The screen's only so big, sometimes it won't show it all. Mine did. In fact, just so you understand, the way that I did this on the calculator, I put 15 in for X, I put 4 in for Y, and then I put -4 in for Z, and then I just typed in -y minus the square root of y squared minus 4 times x times z all over 2x, and then I have my formula ready to go on my calculator. I just got to substitute the values back in or store them into the calculator as we go. But you see, we did end up with the same values that we did right there. The good news about the factoring is that it gives you a little bit more experience with factoring. The good news with the quadratic formula is it can give you extra practice with the calculator and also with the quadratic formula, because all this stuff is likely to be not only on the exam and the assignments, but probably on the final as well. This example, my leading coefficient, it is a phantom 1 right now. I'm going to force it to be that way, by the way, because as long as it's a phantom 1, then I can just factor this out pretty quick. I don't have to use the quadratic formula, so I'm not going to on this one, okay? But I do need to make this all equal to 0. That's crucial. So let's take this. Again, I'm not really treating it like an inequality, but an equality. What I'm going to do is force this to equal 0. So to do that, I would have to subtract 10 w's from both sides. So minus 10w. But also, I would have to subtract 24 from both sides. So minus 24. I know that's kind of weird looking on the left. So I'm gonna arrange this in descending order. So I'd have the w squared minus the 10w, and then minus the 24. Okay, now this is all in an effort to keep that coefficient of w squared a phantom positive 1. I don't want it to be negative. So for those of you that subtracted w squared from both sides, yeah, you gotta take that into account. You can't just say, well, it's just a phantom 1. No, it's a negative if you subtracted w squared from both sides. But the way that I've done it, I've forced this to become phantom 1, which means that when I factor this out, which is what I'm going to do, into two binomials right here, that's going to equal 0, I can do it directly. I don't have to worry about that -1 in the front. So let's see, 24, we've got to, yeah, these would be w's. And then my -24, two values that add up to -10, 6 and 4. Nope, that's not going to work. 12 and 2. Okay, the 12 would be negative, the 2 positive. So I get w minus 12 in the w plus 2. And then those two factors, as usual, if I could get these to equal 0, then I would have a true statement. So if I could get w minus 12 to equal 0, I'd get truthfulness out of this equation. So I would add 12 to both sides, and I get w equals positive 12, which this means if you were to replace 12 into these w's here, you'd get a true statement, but it's the equal part of that true statement. Well, let's try the other one. So again, if I can make w plus 2, if I can make this equal 0, then I would still get a true statement. So minus 2 from both sides, and I get w equals -2, right? We zeroed out these values. Now again, this means that if you replace these w's with -2, you'd still get a true statement, but that's the equal part of that true statement. So now that I have that, let's go ahead and graph this up. So there's my graph. Are you required to show a graph? No, but I like it. It helps me with the intervals. Now over here to the right would be 12 of 0 to the right of 0, and then the negatives to the left, so I got a -2 just to the left of 0 there. And yes, I do not care if they're proportional. What I see up here at the top is that the inequality, now this is the part that's important as well, the inequality showing that it's equal to, which means that these will be closed circles at -2 and 12. So now that I have that, I have some intervals to check. This one to the left of -2, and then in between -2 and 12, and then to the right of 12. So let's get to checking. I'm going to go back to my original inequality, which I recommend doing, always using the original, but you can use the one that you forced to happen from the principles of equality. Just be careful if you do. So mine shows w squared should be greater than or equal to 10 times w plus 24. Now I just need anything to the left of -2. This time, just because we've done it before, I'm going to choose, you can say it's an easy value to work with, but I'm going to choose -5. -10 also would be a pretty easy one to work with, right? But I'm choosing -5. So I've got -5 squared should be greater than or equal to 10 times -5 plus 24. So I got my question mark right there. And I get 25. And I get 25 is greater than -26, it looks like. Now, 25 positive is definitely greater than -26. That's true. So I'm going to put a check mark on that one. All right, so that one's true. Now, like I said before, it should alternate, which means if this one's true, this one should be false, this one should be true. But we're going to make sure, especially since that middle value there is 0. So I'm going to use 0 on this next one. We're saying w squared should be greater than or equal to 10 times w plus 24. But now I'm going to test this with 0. So it'd be 0 squared greater than or equal to 10 times 0 plus 24. This gives me 0 is greater than or equal to 24. Now this is checking, so I got my question mark. This right here is false. 0 is definitely not greater than, it's definitely not equal to either 24. So both of those don't work. I got my X over the interval there. Yeah, let's check this last one. So we got w squared should be greater than or equal to 10 times w plus 24. I just need anything to the right of 12. I'll choose 20 just because, I'm sorry. I'll choose 20 just because I'm going to let the calculator, I guess, do all the work anyway, so not 150. 15. So I got 15 squared should be, in question mark, should be greater than or equal to 10 times 15 plus 24. Now 15 squared, I believe, is 225. And this would be greater than or equal to 150, 170, make it 174. That right there is true. And so, yeah, we get a true statement. I got my check mark there. All right, now be careful because even though we just graphed and we'll pretend like we enjoyed it, it's not done, right? Because it wants the interval, right? We did so much work and it's good work, but make sure you put the actual interval on this one. This is something that we've seen in the past where students miss this interval notation. They do all this work and it's great, but they miss the interval. So don't forget it. Okay, so we know the orange one is good. So I know this goes all the way from -infinity, and then it will stop at the closed dot, which is at -2.
Bracket.
That's included, yep. So we got a square bracket. And then we're going to unite this because the purple one is false. And then starting at 12, which is also included, so square bracket. And then this one also goes, the blue one, goes to infinity, which is never included. And these are our interval